All right, so we saw how getAtterinfo works, also getNameInfo, which is kind of the inverse of getAtterinfo. So let's take a look at the next step in creating a connection. We're going to go through both what the server needs to do and what the client needs to do. But the first two steps, getAtterinfo and actually creating the socket, are the same in both. There might be some different flags we pass in, but we're calling the same functions. So let's take a look at the socket function. So both clients and servers will use socket to create a file descriptor that refers to a potential network connection, one endpoint of the network connection. Just creating a socket doesn't create the connection. We have to take more steps to do that. But in order to do those other steps, we have to have a file descriptor for our socket endpoint. So we can call the socket function. We pass the domain, which isn't a domain name. Here we're passing in the. Here we're actually telling it what address family we're talking about. The type of socket, should it be datagrams, UDP, for example, or should it be a stream, a connection, TCP, for example, and what protocol, which will just be 0 for IP in general. There are some other network address families where the protocol can be different, particularly, for example, if we're creating if we're using some version of the socket function to create raw Ethernet packets. But in any event, we'll be passing 0 for that. So here's an example. Maybe we want to create a IPv4 connection. There are multiple address families, remember. This address family is something that is in the struct sock adder. So if I've got one of those by having called getAtterinfo, for example, without passing in the address family as a hint, then that could be AFINet or AFINet6, and then my program would support either IPv4 or IPv6. Sock stream here is how we specify this is going to be a connection, a stream of bytes, rather than a potentially unordered sequence of packets. And again, 0 for the protocol. The precise way you would call this, what you need to pass in for these, depend on the protocol you're using. Fortunately, these days, that's mostly going to be INET or INET6. But again, we don't want to have to do this twice, and we don't want our programs to only support IPv4. We might as well support IPv6 if we can. So we want to use that getAtterinfo function. Okay, so once we have a socket that's just a file descriptor, what do we do? Well, after socket, the next step would be for the client connect, but we'll get to that later. For the server, it will be the bind function. So bind asks the kernel. All of this networking is done by the kernel, and our programs will use system calls like bind to interact with it. It asks the kernel to take this file descriptor, which had better be referring to a network socket, something that we got from socket, and associate it with a particular address. So that will be a struct sock adder. And then we also have to pass in the length of that struct sock adder. So we can use this to set up a connection on a particular IP address and port. Those are both going to be fields in our struct sock adder. Again, we usually want to get those from getAtterinfo rather than filling out this data structure ourselves. And then we also give the length of that struct sock adder because, again, it's this could be a casted pointer from a struct sock adder IN6 for IPv6, for example, which is longer than a regular struct sock adder. So we want to, the bind function wants to make sure there isn't a buffer overflow. So the meaning of binding a socket to a particular IP address is, or to a particular IP address and port, is that this is the IP address and port number on the local end. So we don't usually use this with clients, but it is possible. Usually, when we make a connection with the client, we specify which remote IP address we want, but this is the local IP address. On a client, there's often only one of those, and if there are multiple ones, the kernel can pick the best one based on what IP address we're trying to connect to. So we don't usually have to worry about that on a client. Likewise, for the port number, clients usually get ephemeral port numbers that are picked by the kernel, rather than well-known port numbers like 80 for HTTP or 443 for HTTPS. So we usually don't need to specify that either. So in our diagram, it showed bind as only happening on the server side. Some client programs will use bind occasionally, particularly if they want to set up if they want to work well with computers with multiple IP addresses. For example, something like a Tor proxy, where you have a tunnel connection to a private network, or a VPN, for example, might do bind on the client end to make sure that it is talking on the client's real IP address and not on our tunneled or virtual IP address. All right, so so on a server side, we've used socket to create the socket. We've used bind to associate it with a particular address. And now we'll listen for connections. So the listen system call takes a file descriptor referring to a socket and takes a hint about how many outstanding connections should we let pile up before we start refusing requests. And then it will set that socket up to be a listening socket. We'll see a little more about the different kinds of sockets on the server side in a moment. So after we've started listening, then we call accept. Now accept will wait until someone tries to connect to us, assuming we've set up the socket as a listening socket. And when they have, well, then what? So accept takes the listening file descriptor. So this is the one that we got, from socket. Then we called bind. It's specifically listening file descriptor, so we should have called listen on it. We give it a pointer to a struct sock adder and a pointer to the length of that. This is actually going to be a buffer, rather. So it will be an output parameter of accept. It will be filled in. So we also need to pass the length of that buffer. And remember that the size of a regular struct sock adder isn't necessarily big enough for IPv6, for example. So we do have to be careful there. But it also returns an integer. So when a connection comes in, accept will create a new file descriptor. So the listening file descriptor is still there. It's still listening for connections because multiple connections might come in. Accept returns a new file descriptor that is a connected file descriptor. This is one that we can write to talk to the client, read from to get things from the client. And it will also fill out the client's address into the struct sock adder. So that'll be the IP address, but then we can use get name info to convert that back into a host name or to a string IP address. All right, then So on the server, we did that sequence of 5 steps: get attr info, socket, bind, listen, accept. We've kind of left the client behind for a little bit. The last thing it did was socket, but now connect. So connect, we tell it the file descriptor. This is the one the client got from calling socket. It probably didn't call bind on, but it might have. It should not have called listen. And we give it the address of the server as a struct sockadder. So again, that's something we're going to get from get attr info. If the connection works, then client FD is a connected file descriptor. We can write to it to send things to the server, read from it to wait for the server to send things to us. And then the port number for the local connection is going to be assigned an ephemeral port number, unless we did use bind previously. So here's an example of accept working. So the client, remember, is going to call connect. The server has made a listening file descriptor. So it got this by doing socket, bind, and listen. It then calls accept, which blocks, meaning it waits for something to happen. Once that connection happens, then connect will do its thing, listen will do its thing, return a new file descriptor. So that might be file descriptor 4, for example. And now the client's file descriptor that it passed to connect, and the server's file descriptor that it got as the return value from accept are talking to each other. The server's listening file descriptor is still there, so it can still wait for more connections to come in, so we can handle multiple clients at the same time, potentially. All right, so we've seen 2 kinds of file descriptors. Again, this is related to the server side. Listening descriptors. We can't read from a listening descriptor or write to it. All we can do is wait for new things to come in, or do things like bind to change its parameters. A connected descriptor, that's the thing that we either on the server side got from accept, or on the client side we passed to connect. We can write to and read from, talking to the other end of the connection. This will only exist as long as it takes to do the service. Once the client closes the connection, the server will see that and close its side of the connection. And the listening one, on the other hand, will exist for the entire lifetime of the server, or at least until we need to start listening on different ports or so on. We might or we might recreate that file descriptor in that case. All right, so next we'll take a look at how to read and write on one of these connections, but we'll see that in another video. So thanks a lot.